Good morning, students. Today in this module we will learn how to interpret physical features from a topographical map. Let's begin. So the first thing we will learn is about slopes, and if we categorize slopes broadly, then there are two types, gentle or dip slope, and the other one is steep or scarp slope. Now in case of a gentle slope, you can see the slope will fall gradually, whereas in case of a steep slope it will fall suddenly. So our motive is to see the contours and how these slopes are represented in a topographical map. So when the slope is steep, the contours will be closely spaced. Students, you can see here the difference between contours is 100 meters. The first one is 200 meters and the next one is 300, 400, 500, 600, and if we move to the center, the height there is 700 meters. And you can see this side the contours are close to each other, whereas on this side the contours are far from each other because this side of this particular landform has a gentle slope. If we say this is a hill or a hillock, it's not a hillock rather, because the height if we see is 700 meters. So rather it's a mountain. So if it is a mountain, then one slope, this slope is steep, and that's why the contours are closely spaced. Whereas the other slope is gentle, and that's why here the contours are widely spaced. Now students, let me tell you, if this contour has a reading 400, then though it is joining from wherever the contour is passing, it is joining places with the height 400 meters above sea level. Similarly, all the other contours, if it is 200, then from wherever this contour is passing, it is joining all the places and their height is 200 meters above sea level. Then the next one is higher, the height is 100 meters more, 300, 400, 500, and so on. And the center, that is the highest part of this landform, is having the height of 700 meters. So this is a general concept of how we show slope in a topographical sheet, or how can we understand the nature of slope. If it is closely spaced, it will be steep slope or scarp, and if it is widely spaced, it will be gentle slope or dip slope. Let's proceed. Now we will learn about different types of slope, and the first one is a uniform slope. So students, how a uniform slope will look like if we learn the contours in a topographical map. So when the contour lines are evenly spaced, they form a uniform or regular slope. So the uniform slope is also known as regular slope. See this. In a topographical map, suppose this is a slope which is, you can see gradually it's falling, so it's a uniform and regular slope. It's nowhere that there is a sudden drop or rise, so the slope is evenly falling, dropping down. So we can see this contour is showing the lowest portion, and we can see the contour interval is 50. When the first one is 50, then the next one is 100, 150, 200, and so on. So we can see the contour difference or interval is 50. So as the height is increasing, as the slope is rising, we can see these contours are evenly spaced, means they have almost same gap between two contours. So this shows that in a topographical map, if we find this kind of a structure or a formation of contours are drawn in this way, then we will say this region is having uniform or regular slope. Let's proceed. Next one is irregular slope. So there is a combination of dip and scarp. Now children, we have learnt just before this that dip slope means gentle and scarp means it is a steep slope. So they are formed alternately because in such case the contour lines are spaced irregularly. So the part which has contours marked closer has steep slope, and the contours far apart show a gradual or dip slope. Now students, If you have a confusion in this, it will be clear by looking at this picture. So this is the contour and this is the landform. Now children, you can see the landform is irregularly sloped, means there is a sudden rise, sudden fall, it's not uniform. Unlike the slope we have seen just before this. In that picture we have seen that the slope was falling regularly, but in this case the slope has ups and downs. So how the contours will be in the topographical map? You can see the contours are very close to each other when the slope is suddenly rising or falling, and again they are widely spaced because it is uniform out here. Again there is a rise and fall, again the contours will come closer. So this is an irregular slope where you will find both. It's a combination of dip and scarp, steep and gentle slope. The next one in the list is a convex slope. Now what happens in a convex slope? In a convex slope, the contour lines are closer together in the lower part of the slope, while they are further apart in the upper part of the slope. So students, you know how a convex shape looks like. Let's look at this picture. This is the picture of a typical convex slope. You can see this one, this portion is convex. So now as this slope is rising, you will see the contours, they are closely spaced, and again when it has become gentle, you will see the contours, they are widely spaced. So this is how a convex slope looks like, and if this kind of contours you will find in the topographical map, you can easily identify that this area is having convex slope. Now the next in the list is concave slope. In a concave slope, the contour lines on the lower part of the slope are widely spaced, while those on the upper part are closely spaced, or they are closer together. Let's look at the map. So in a topographical map, if we see this kind of a structure where the lower portion is widely spaced, but as there is a sudden rise, the contours will also be drawn very close to each other, because the sudden rise is there, so the contours will quickly change its value and there will be a lot of contours drawn close to each other. So this kind of contour drawn in a topographical map will show you and signify a typical concave slope. You can see the concave structure, it's depressed here. Let's proceed. Now a stepped slope. Now children, stepped slope is also known as terraced slope. When few contour lines are found closer and few wider apart, this pattern of arrangement is known as terraced slope or stepped slope. So it's like a step. Let's look at the picture. So if we find this kind of contour arrangement, you can see children, this slope, there are grooves. So this is also a type of irregular slope. We have learnt about irregular slope. So this is also an ununiform or irregular slope. It is known as stepped slope. You will see suddenly the contours are coming closer, then wide apart, again coming closer. So like this, a stepped slope can be seen in a topographical map. Now students, we will learn about some features by reading the contours in a topographical map. The first one is a conical hill. So how does a conical hill look like in a topographical map? A contour of a hill or a mountain is in the form of concentric circle. Now children, this is important. You will find them in the form of concentric circle. A conical hill rises almost uniformly from the surrounding regions in the shape of a cone. So what kind of shape it will acquire? It will acquire the shape of a cone. Let's look at the picture. Yes. So this is how the contours in a topographical map represent a conical hill. Now students, you might have a question that ma'am, how we will distinguish between a hill and a mountain? So students, you will see the highest value, that is the height of the peak, it is just 90 meters above sea level. So it's not very high, so definitely it will be a hill and it will not be a mountain. So you will find them in the form of concentric circles. The contours will be arranged in this way, and this is how it is represented in a topographical map. Next is ridge or mountain. Now students, we should know first what is a ridge. Mountains are landform which are much higher than the surrounding. They have a peak, conical peak, and they usually have steep slope. But what is a ridge? And if we know mountain, what is a mountain range? So ridges and mountain ranges are chain of mountains having long narrow summits. Summits mean peak. The edge of a ridge may be gentle or steep. So the edge of a ridge can be gentle or it can be even steep. The elongated contours, elongated means these contours are arranged in such a way that they give you an impression of elongated structure. So many circular peaks, you will find several small peaks, and the area will be shown with the help of elongated contours. The only difference between ridge and a mountain is that the mountains are higher than the ridges. So the height of a mountain is always more than that of a ridge. Let's proceed. See, this is how a mountain is shown. This is how a mountain is shown in a topographical map. You can see the highest portion 400 meters above sea level. See the contour interval 100, 150, 200. So the difference is 50. So here the contours, they have an interval of 50. And this is how a mountain is shown in a topographical map. This is the picture of a ridge. Students, you can see the peak is there and it is elongated. The contours are elongated. See, there are several peaks, 1, 2, 3. Though only one is shown in this, but there are several peaks. So a ridge has a series of peaks also, and the contours are in elongated form. Now knolls. What are knolls? They are small isolated hillocks that appear more or less rounded and are represented by almost circular contours. So see the picture. Students, you can see this. The height is also less. Along the river you can see small knolls are there. Their height is not more than 150 meters above sea level. Now how we can find plateaus in a topographical map. Plateaus are large, fairly flat pieces of uplifted land surrounded by steep slopes. So students, this is a plateau higher than the surrounding. It has a steep slope. So this type of landform is known as a plateau. Let's see how it is shown in a topographical map. Now students, this is a plateau. This is the contour arrangement. You can see that the center is almost flat and there are no values here because it shows that the upper portion, the topmost part of the plateau is almost flat. The contour lines are quite close to each other all around because the slope is steep. While on the upper slopes there are no lines or hardly any line, signifying that the top is rather flat. So you will see the contours are usually close, and see the pattern. It's not like circular or concentric, rather it has a different pattern, and the top you won't see any contours or a peak is not shown because it has a flat base or a flat top. So this is how a typical plateau can be seen in a topographical map. Now the next landform is an escarpment. The landform which is escarpment has steep slope on one side and gentle slope on the other side, represented by closely spaced contour on one side and contours marked far apart on the other side. Now students, let's see the picture. This is an escarpment. You will see one side the contours are closely spaced, whereas on the other side they are widely spaced. Why? Because one side the slope is very steep, whereas the other side the slope is gentle. This is what a typical landform is known as a escarpment. Now the next in the list is a cliff. You know what, cliffs are usually formed by the erosive action of seawater. So mostly a cliff is either facing a sea or a lake. So a cliff is a very steep rock. It is identified by contours which run very close to one another and finally merge into one. The closer the contour lines to each other, the steeper is the slope of a cliff. You know, cliff has almost a vertical wall-like structure, and as it becomes vertical, so it happens that the contours become so closely spaced that they merge at a point. Let's see. Here students, this is a cliff and you can see here this is sea. Ocean water has carved or given shape to this landform, so it is almost vertically straight. You can see that the cliff is vertically, the slope has become almost straight. So the contours have come so close that they are merging at one point. So this is how a cliff is shown in our topographical map. Next in the list is a spur. So spurs are elevated regions that separate one valley from another. So let's see first what is a spur. You can see this region, this portion of a slope. It separates, now this is the valley, but this is known as the spur. This side is the valley, and if we go up, it's the peak of the mountain or the hill. So this portion is known as a spur. Now how does it look like in a topographical map? It looks like this. It has a V structure, and students, the lower apex means the pointed part of the spur, this landform, is towards the lowest elevation. So you can see how it's increasing, the value is increasing as we are moving upward. So definitely this shows the lower portion, and as we go up, this shows the upper portion. So you can see as the height is increasing here, the value is also increasing here. So this is how we show a spur in a topographical map. Let's proceed. Next one is a valley. Now children, you are very well acquainted with what is a valley. Valleys are long narrow depression between two elevated lands. A valley is usually occupied by a stream. The elevated lands on either side could be mountain ranges and two mountain ranges or even two spurs. So an elevated land on either side could be, means if valley is a depressed portion between two mountains, so the elevated land on both sides, either side of the valley could be mountain range, it could be two mountains or even two spurs. So just now we have learnt about spur, so it can even be two spurs that is in on both the sides of a valley. So the contour of a valley are V-shaped like those of a spur. However, the apex of V point toward higher elevation. Now students, if this is of a contour of a spur, so you can see the apex is towards the lower elevation, but in case of a valley, this is a valley, you can see the valley is here, and you can even see the arrows which are showing the river is flowing down the valley. You can even see the arrows here, this showing the river. So you will see the apex, the letter V, can you see the letter V here? And you will see as we are moving up, the value is increasing. So the highest portion of the valley has the reading, means has the highest value. Whereas in case of spur, the apex had the lower elevation, but in case of a valley, the apex has the higher elevation. So I hope you have understood this. Both the pictures show the structure of a typical contour structure of a valley in a topographical map. Now pass and gap. If the break between two peaks is very high, it is called pass. Now students, if the break means there are two peaks like this, if the break, this is the break. So if it is too high, then it is known as a pass. They are low points or opening between two peaks in a range of hills. If this break is lower or closer to the valley floor, it is known as a gap. Now children, if this pass becomes very low, it becomes further eroded and come down, then it is known as a gap, and often the gaps are occupied by rivers. So often you will find rivers flowing along the gap. Let's look at the picture. So this is a pass. You can see the reading, this is 210, 170. So this higher areas, the lower portion, little lowered portion, you can see the higher elevation on both sides, and when there is a little lowering or break between two, this is one mountain range, there is a second one, the mountain peak, and if the lowering or the break is not very deep, then it is known as a pass. Now this is a gap. Now if the lowering becomes very deep, if the pass becomes further deeper, or if anywhere else a deeper gap, deeper depression is formed, then it is known as a gap, and you can see it is often occupied by a river. So you will see the river flowing along the gap. So you can see that the river is coming down, you can see the arrow which is indicating the flowing of a river along a gap. You can see the value is high and moving towards lower elevation, here also moving towards lower elevation. So it has lowered so much that it has formed a gap. Next in the list is coal. Coals are formed when the land between two streams in a watershed has been reduced considerably. In the contours, this is indicated by a drop in height of the watershed in the region of a coal. Now students, you should know what is a watershed, and then I will explain you what is a coal. Look at this topographical part of a map where the coal is shown with the help of contours. So this is a coal. Now children, this is watershed, means river drain a large area. The arrow is showing river and this arrow is showing the another river. So this is river 1 and this is river 2. So this river is flowing and draining this area, and this river is flowing and draining this particular area. So this is its watershed, and this region is the watershed of river 1. Now this area which is in between watershed number 1 and watershed number 2 is known as a coal. Now river also does headward erosion. So the headward erosion is also happening, and this region is becoming narrower, and when it has become narrow because of the headward erosion by the river, then it is known as a coal. So this is how a coal is shown in our topographical map. Now the next in the list is saddle. If there is gentle slope between two peaks in a low range, it is called saddle. Now students, if there are two ranges of mountain, and if there is a gentle slope between them, so that particular depression or the lowered area is known as a saddle. They are shallow depressions between two summits. Let's see, this is a saddle. So you can see this is a peak number 1 and this is peak number 2, and the height is not very much, only 250 meters above sea level. So it's not very high, but this depressed area where the elevation is little low, this is known as a saddle. Both these peaks, they have gentle slope, and this shallow depression, it's not very deep, is known as a saddle. Now next is waterfall. Waterfalls are formed in mountainous areas when rivers fall suddenly and almost vertically in their course. Now students, all of us have seen in the TV or in the pictures of about a waterfall, that how it looks like. We have seen a typical waterfall where water falls from a great height, and this energy is also used to harness hydroelectricity at many places. So in the topographical map, the contours are very close together or may even touch each other. If you remember of a cliff, in case of a cliff also, when it formed a vertical wall-like structure, all the contours merge at a point. Similarly, in case of a waterfall also, even if they are not merging, they come very close. You can see children, this arrow is of a river, and this is a waterfall. Here you can see they have become so close, the height has increased, you can see, and the water is dropping from a great height. So this is a typical picture or the pattern of waterfall in a topographical map. In topographical map, this falls, usually the word falls is written, and next to it the height of the waterfall is also written. So you can easily identify this by seeing this kind of typical arrangement of contour and the word falls along with the height mentioned in the topographical map. Friends, here in this picture we will see the pattern of contours used to show different relief features in a topographical map. So let's start from this. WF stands for waterfall. You can see the contours are so close and the water is falling from a great height. Here you can see the value of the contours, they are reducing as we are moving downwards. So this is how a waterfall is shown. Now let's proceed. Here we will see S. Can you see the letter S? This stands for saddle. Just now we have learnt between two mountain peaks which are not very high and they are having gentle slope. The shallow depression between them is known as a saddle. And these arrows on the map, students, they show the river. These are the streams which are meeting this main river. R stands for, and R and G, they stand for river gap. So river gap, we have learnt about gap, that when the area between two mountain peaks, they reduce the height, reduce so much that they almost reach near the valley floor, and they are known as a river gap. And the name is river gap because the gap is often occupied by a river. So can you see the river? The river has occupied this gap. Now here you can see the letter P stands for plateau. So plateaus, we have discussed, has a broad top. So the top area is broad and you can see the height is increasing. Now let's proceed. Here we can see scarp. Scarp stands for steep slope. Here you can see the contours are close, and dip stands for gentle slope. Here you can see the contours are widely spaced. Now here R stands for ridge. We have learned, students, that ridges, they have elongated pattern of contours. You can see the elongated pattern. Here the letter C stands for cliff, and we have learned that cliff is almost a vertical wall-like structure, and when it becomes vertical, the contours come so close that they almost merge with each other, and this is how they are merging. We can see it clearly in this picture. So students, this picture shows us about some typical landforms which we can learn with the help of by reading contours in a topographical map. Here is the list. C stands for cliff, WF for waterfall. So like this, it's written here, the nature, how they are shown in the topographical map. When you read this and we also see this picture, we'll understand the features in a better way. Now students, here is a part of an extract of Survey of India map sheet 45D by 10, and the eastings are from 14 to 24 and northings are from 2 to 12. So with the help of this part of this extract, I would like to show you certain physical features in this particular part. So here you can see the contours which I have over the contours I have drawn again to make it little darker so that you can understand the part of a plateau. You can use the sheet which you have, the same sheet, and you can see the contour pattern and you will understand the arrangement, and this is showing a plateau. If you come here, you can see the peaks in between and then elongated pattern which is showing a ridge. Here we can see the contours are widely spaced and this will signify a gentle slope, whereas here the contours are very close. So this is showing a steep slope. Further, in this portion of the map, we can see mountain. the concentric pattern, but we can see how the contours value is increasing, and at the center there is a conical peak, so it shows a mountain. Whereas in this part we can see small hills and hillocks and knolls which are scattered. You can see small mounds, they can be seen in this part of the map. So students, you can see that this sheet, it is with you and you will understand it better. So thank you student, that's all. We have learned how we can show or we can find out the physical features in a topographical map by reading about the nature of the contours.